We will solve this problem. This is an example of system of linear equations. We will solve this using LU decomposition. We have here three equations with three unknowns. We have x1, x2, and x3. First, we will rewrite this system of equations into a matrix equation. So this is our matrix equation. This is our coefficient matrix. This is the variable matrix, and at the right side of the equation is the constant matrix. We can express this equation in the form of AX is equal to B. The value of X, or the values of X1, X2, and X3 can be solved by the following procedures using LU decomposition. So these are the procedures. We will let the matrix A equal to L times U. L is the lower triangular matrix and U is the upper triangular matrix. We will substitute the value of A to the equation of AX is equal to B. Thus, our equation now is equal to LUX equal to B. Second, we assume that UX is also equal to Y. Then, LY is equal to B. First, we have to solve the value of Y using forward substitution method. From this equation, LY is equal to B. After getting the values of Y, we will solve the value of X using back substitution method. From this equation, UX is equal to Y. Okay, we will now start for our computation. We will write our augmented matrix. So this is our augmented matrix. In this problem, we will derive the LU decomposition based on the Gauss elimination with row pivoting. Okay, so for Gauss elimination, the first procedure is to use forward elimination of a known, which we have to reduce the set of equations to an upper triangular system. We will eliminate the first unknown of this problem, which is x1. Then for the second unknown, we have x2. Then for the third, we have x3. Okay, I have to move this to the right. Okay, for the first row, our pivot is equal to 4. We have to copy these elements of the first row in the next augmented matrix. Then, this one, the first element of the second row and also the first element of the third row, we have to make this all equal to 0. And the remaining elements of row 2 and row 3, we will have to change this. I have to write here my pivot. Okay, my pivot row because it contains the pivot element, which is 4. Then we have to find the factor or the multiplier of row 2 and row 1. So we have here M21. So again, for the first subscript, that is the number of row where the element lies. And the second subscript, it designates the number of column where the element lies. So for the M21, we have to get the factor or the multiplier of row and row 1 to eliminate x1. So we have to divide negative 2 to 4. So that is equal to negative 1/2. Then for row 3, we have M31. We have 1 divided by 4. That is equal to 0.25. I have to make this in a decimal form. So this is negative 0.5. And this is 0.25. So these are our multipliers. We'll multiply these factors or multipliers to the elements of row 1. Then the results, we have to subtract it from the elements of row 2 to eliminate x1. Then similar procedures we will use to eliminate x2 and x3. We will have to write the new augmented matrix here. So we have x1, x2, x3. Okay, so we have to write all the elements of the first row because it contains our pivot element, which is equal to 4. Then for the second row, we have negative 2 minus negative 0.5 times 4. Okay, that is equal to 0. Then we have negative 4 minus negative 0.5 times 3. That is equal to negative 2.5. 5 minus negative 0.5 times negative negative 1. It is equal to 4.5. Then we have 20 minus negative 0.5 times negative 2. Okay, you have 19. For the third row, we have here 1 minus 0.25 times 4. Okay, I have to change the color. Okay, so we have 1 minus 0.5 times 4. That is equal to 0. Then we have 2 minus 0.25 times 3. That is equal to 1.25. Then we have 6 minus 0.25 times negative 1. So that is 6.25. Then 7 minus 0.25 times negative 2. So you have 7.5. Okay, so we have now a new augmented matrix of our equations. So next pivot for the second row, we have this pivot that is negative 2.5. So we have here to eliminate x2. So we have here our multiplier. We have, this is third row and the column is second column for row 2. So again, you have to divide 1.25 divided by negative 2.5. So this is equal to, okay, this is equal to negative 0.5. So I have to make this again in a decimal form. So you have 0.5. Okay, so we have to write again another augmented matrix. So we have x1, x2, x3. Then we have here, we have to copy the elements of our elements of the second row of our new augmented matrix. So we have 0, we have 2.5, okay, and 19, because our pivot is negative 2.5 for row 2. So you have to copy the elements of the row that contain pivot element. Okay, so we need to find the value or the elements of the third row. So again, we have to subtract. Okay, so we have here to subtract the elements of row 3 to the elements of row 2 multiplied by a factor. So we have here 0. Then for here, we have 1.25 minus negative 0.5 times negative 2.5. So this is equal to 0. Then we have 6.25 minus 0.5. Okay, 6.25 minus negative 0.5 times 4.5. So that is 8.5. Then we have here 7.5 times, 7.5 minus negative 0.5 times 19. So this is equal to 17. So after forward eliminations, we reduce the set of equations to an upper triangular matrix. So as you observe, all the elements below the main diagonal line are equal to 0. To substitute some of these values to this matrix of our A is equal to L times U. So for our matrix A, we have to copy the elements. Okay, so for our matrix A, this is your matrix A. Which is equal to lower triangular matrix. So for lower triangular matrix, we have to substitute the multipliers. For M21, we have negative 0.5, M31 0.25, M32 is negative 0.5. So we have negative 0.5. Then all the main diagonal equal to 0. Then you also have 0.25. Then you have 0.5. Okay. So we have that matrix. Okay, so for our U, we solve this one. So this is our upper triangular matrix. So we have to copy. So we have U12, you have 4, U13 is 3, then U14 is negative 1. Then 0, U23 is negative 2.5, then U24 is 4.5. Then we have also 0, 0, then U34 is equal to 8.5. Okay, so we have 8.5. So this is now our matrix for A equal to L times U. From the procedures of LU decomposition, we will first solve the y from this equation. Ly is equal to B using forward substitution method. Okay, so for our matrix, for lower triangular matrix, we have 1, 0, 0, then negative 0.5, 1, 0, then you have 0.25, negative 0.5, 1. Then for our vector y, we have y1, y2, and y3. Then this is equal to constant. So our constant matrix, we have -2, 20, and 7. Okay. -2, 20, and 7. Okay, so from our matrix, for the first row or for the first equation, we can directly determine the value of y1, which is equal to -2. Then for our second equations, we have to find the value of y2. So we have here 0.5 y1 plus y2 is equal to 20. So we will substitute the value of y1, which is -2, plus y2 is equal to 20. So -0.5 times 2, that is 1, plus y2 is equal to 20. So we have y2, which is equal to 20. We have to transpose the constant to the right side, and we have to change the sign. So this will become -1. So y2 is equal to 20 minus 1, that is 19. For our y3, for the third row and for the third equation, we have 0.25 y1 minus 0.5 y2, okay, plus y3 is equal to 7. So we will substitute the value of y1, that is -2, minus 0.5 y2, that is 19, plus y3. Okay, and this is equal to 7. So 0.25 times -2, this is equal to -0.5. Then we have -0.5 times 19, that is 9.5, plus y3 equal to 7. So again, we have to transpose the constants to the right side, and we have also to change the sign. So y3 is equal to 7. So this is positive 0.5 plus positive 9.5. So 7 plus 0.5 plus 9.5. So y3 is equal to 17. So we have now the values of our vector y. Then after getting the values of y, we will solve now the value of x from this equation. Ux is equal to y. So here, our upper triangular matrix. So we have to copy this one. Okay. We have to write again our matrix in the form of Ux is equal to y. So, okay. So we have here x1, x2, x3. And our values for y1 is -2. Okay, we have here -2. y2 is 19. And y3 is 17. Okay, so we will determine the values of y using back substitution method. So we will start at the lower portion or at the last equation. So that is in our third row. So we have here x3 is equal to, okay, we have 8.5, x3 is equal to 17. So x3 is equal to 17 divided by 8.5. So this is 17 divided by 8.5. Okay, that is equal to 2. Then our x2, so we have second equation, or the second row, we have 0, that is negative 2.5 x2 plus 4.5 x3 is equal to 19. So here we have to substitute the value of x3. So we have to compute the x2. So we have 4.5 x3 is 2 equal to 19. So we will transpose the constant to the right and change the sign. So 4.5 times 2, that is 9. So this will become negative 9. So x2 is equal to 19 minus 9, that is 10 divided by 2.5. So x2 is equal to 4. So the sign is negative. Okay, so for x1, that is the first equation, we have 4x1. So we have 4x1 plus 3x2 plus 3x2 minus x3 equal to negative 2. So again, we will compute x1, then we will substitute the value of our x2 and x3. So that is 2. Okay. So 4x1 is equal to 3 times negative 4. So this is negative 12. Negative 2 is equal to negative 2. So this can be equal to 0. So your 4x1, we have to transpose 12 to the right. So this will become positive. So x1 is equal to 12 divided by 4. So x1 is equal to positive 3. So these are our answers for x1, x2, and x3. To check, you can check your answer. So I want you to check your answer. So you have to substitute the values of x1 and x2 for our equation, or to our equations. So we have here 3 equations. So we will have to check in order for us to know that our answers are correct. So from equation 1, so let's say from equation 1, okay, from equation 1, so you have 4x1 plus 3x2 minus x3 is equal to 2. So we have 4, okay, x1 is 3 plus 3x2, x2 is negative 4, negative 4. Then x3 is positive 2, that is negative 2. So this can be equal to 0. Then what remains is negative 2, which is equal to the right. So this is correct. Again, from equation 2, we have, from equation 2, okay, we have negative 2, x1 is 3 plus, okay, that is negative 4, x2 is negative 4 plus 5, x3 is negative, okay, x3 is negative, okay, positive 2, positive 2 equal to, okay, equal to 20. So we have here negative 6 plus 16 plus 10 equal to 20. So negative 6 plus 16, that is equal to 10. 10 plus 10 is equal to 20. So again, this is correct. Left side value is equal to the right side value. Okay, for the last equation, we have equation 3. So we have x1. So that is 3, okay, plus 2x2. So 2x2 is negative 4 plus 6x3. 6x3, so x3 is 2, equal to 7. Equal to 7. So we have 3. Okay, this is negative 8 plus 12 equal to 7. So 8, okay, 3 minus 8, that is negative 5. Then negative 5 plus 12, so that is equal to positive 7. So again, the value of the left side is equal to the right side. So this proves that our answers for x1, x2, and x3 are correct. So I hope you understand, and thank you for your time in watching this video. Okay, so thank you.